All right, here we are writing the complete ground state configuration of copper plus. Now copper has 29 protons, which would be 29 electrons if it was neutral, but it's positive. So that means with a positive, you've lost one electron. So we have 28 electrons. So we're going to start our configuration, 1s2. So there's 2 electrons, then 2s2, 2p6. So we're at 10. Then next is 3s2. That's 12. 3p6. Now we're at 18 now, 28. So we have 10 left. So the way this typically goes would be 4s2 would be next, and then 3d8 would be our 28. Now we talked about a few exceptions with these, and that usually happens in this S to D range. And so what is more energy efficient is to have a large set of orbitals filled. So having the D filled is more beneficial than having the S filled. So we're actually going to transfer 2 of these to the 3D10 and not do the 4S. Now that's because we have 1S, 2S, 2P, 3S, 3P, and then we have 4S, 3D, 4P. The energy levels here get pretty close together. So there's not a huge benefit to having this filled over this D orbitals, but there is a benefit to having our D filled all the way. So instead of just leaving it like that, we can pull those 4s electrons and fill it completely. So that is more energy efficient. So when we're looking, so it's to get something half filled. Oftentimes, if we can get the D either half filled or completely filled, even if it means leaving an S, half filled, there's some energetic benefits to a half filled or fully filled L, right? Sublevel P, S, P, D orbital, and especially those Ds and Fs, than having an S completely filled, especially when you're up here in the higher energies where they're really close together. So we're going to do it with a 3D10 and not leave the 4S. And here we are, 3P. And so instead of 4S2, we're going to go 3D10. There we go. So this is a tough one where we're looking for those energy efficiencies in that D orbital, which can be tricky.